Okay, the arguably the most difficult lesson in the entire unit is lesson day 3, lesson 1, independent and dependent events. So this is probably the most difficult one to grasp, but we'll give it our best shot here. So first of all, dependent and independent events. A compound event is when two or more things are happening in succession. So example, you're drawing a card and then you're flipping a coin. So in succession, that's a compound event. If it is independent, so that means the cards don't, whatever happens with the cards does not interfere with the coins. You draw a heart, it doesn't change the probability when you flip the coin. When it's independent like that, it's very straightforward. So what is the probability of rolling a 3 with a dice and drawing a 3 from a deck of cards? So 3 with a dice is 1 out of 6 chance. And a 3 with a deck of cards is 4 out of 52 or 1 out of 13. And when you have things in succession and the word and, so you need to roll a 3 and draw a 3 from a deck of cards. And means multiply. So you just multiply them. And that's fairly straightforward. In some situations involving compound events, the occurrence of one event has no effect on the other, and that's independent, like I just said. And straight multiplication, doesn't matter how many events happen, A, B, C, D, you can go forever, and you just keep multiplying. So, coin is tossed 4 times and turns up heads each time. What's the probability the next toss will be heads? Well, the previous tosses don't indicate anything. The next toss is 50% chance, or 1 out of 2, that it is heads. What is the probability of tossing 5 tails in a row? 5 tails in a row is a little different. It's half times half times half times half. It's half to the power of 5. Again, they're independent. One toss doesn't affect any future tosses. In some cases, probability events depend on the outcome of another event, so they're dependent on each other, and that's conditional probability when dependent events occur. One event depends on the other. So conditional probability formula, probability of B happening given that A happened is equal to the probability of A and B happening divided by the probability of A. So that is the one you have to memorize. Another way of looking at it is you could do N of A and B divided by N of A. So N of A is, again, the number of ways A can happen. And N of A and B would be the number of ways A and B can happen. So you can use N instead. Okay, so what's the probability of rolling a sum greater than 7 with 2 dice when it is known that the first die is a 3? So if the first die is a 3, so you've rolled a 3 with the first one, you got to get greater than 7. There are 2 options. And that would be the numerator. Greater than 7 and of rolling a 3 on the first is 2 out of 36. Now, the probability of just getting a 3 is, well, if you roll the 3, you've got 6 other options here. Oops. Let's get back to what we were doing. Here we go. So if you rolled you wanted a 3, you've got rolling a 3 is 1 out of 6, or you could consider it as you've got a 3 here. And how many other options would there have been? Well, you can get a 3 with a 1, you can get a 3 with a 2, you can get a 3 with a 3, you can get a 3 with a 4, 3 with a 5, 3 with a 6. So that would be 6 out of 36 as the denominator. So at the end of the day, 6 out of 36 is 1/6. It's the same answer. And you end up with a cancellation of the 36 denominator. And it would have been 2 out of 6. So what I'm saying is you get 2 out of 36, and this could be 6 out of 36. So 6 in the bottom, 36 at the top. They would cancel out, and you get 2 out of 6. 2 out of 6 is 1/3. It's the same answer as you got here. But it doesn't really matter how you do it. If you follow the formula here, or you try to do the N of A version, where you've got roll of 3. How many ways can you be above? There's 2. Roll of 3. How many other numbers could you get? Well, there's 1, 2, 3, 4, 5, 6. 6 out of 36. And you can look at it that way. It doesn't really matter which. You'll get the same answer. Depends on how you see it. Let's try another example here. Family of 2 children is chosen at random. Find the probability that there are 2 boys if it's known that one is a boy. Or there are 2 boys if it's known that the first one is a boy. Now, those are different. So, first of all, there are 2 boys if it is known that one is a boy. If you know that one is a boy, probability of at least one boy is 3 out of 4 on the bottom. And 2 boys and at least one boy is just 1 out of 4 on the top. When you switch it up, it ends up being 1/3. So multiply by the reciprocal, cancel out the 4s, and you get 1/3. Now, there are 2 boys if it's known that the first one is a boy. So if it's known that you've got a boy as number 1, you've got boy, boy, or you've got boy, girl. What's the chances of a boy, boy? It's 1 out of 2. So taking you through the full process, first of all, probability of a boy first is 1/2. And probability of 2 boys and boy first is still considered 1 out of 4. When you do the reciprocal, it's 1/2. And the way I like to think of it, rather than go quarter and 2 quarters, is, as I said, if you know that you've got boy first, you either have boy, boy, or boy, girl. And if you're looking for the probability of boy, boy, given that you have boy first, boy, boy is 1 versus boy, boy, or boy, girl. That's the denominator, which is just 2. So it's 1/2. And if you can logic your way through it, sometimes it's a little bit easier than following the full process. This is easy if you follow the process. You try to think your way through this, it might get a little more difficult. So outtake is an email program. Probability of outtake freezing, stops responding to commands. And the operating system crashing afterwards is 1%. So that's an A and B situation. Freezing and crashing is 1%. Probability of outtake freezing is 2.5%. If outtake is freezing, what's the probability the operating system will crash? So we got to organize what we have. Freeze and crash is 1%. Freeze is 0.025 or 2.5%. Crash given freeze is what you're looking for. So filling in your values, crash and freeze is 0.01, freeze is 0.025, and you get your answer. There's a 40% chance. If it's already frozen, there's a 40% chance that it's going to freeze or it's going to crash. Already frozen, 40% chance it's going to crash. And there, just following the formula makes it nice and easy. Probability it will snow tomorrow is 0.6. Probability it will snow the next day is 0.2. If it snows tomorrow, the probability it will snow the next day is 0.2 if it snows tomorrow, and 0.75 if it does not snow tomorrow. First, draw your probability tree. So first of all, it snows tomorrow is 0.6. 0.4 is no snow. Now, from the snow, you know it will snow again at 0.2. Always following 1 minus, you know 0.8 is no snow. And then if it didn't snow tomorrow, that's the 0.4, because 1 minus 0.6 gives you 0.4. That gives you no snow. And then from there, it said 0.75 is the probability of snow the second day if it did not snow the first day. So 1 minus is 0.25, and you can fill in the values. Just remember, with the probability tree, if you got a percentage or a probability for the one, you know 1 minus is going to give you the other if there's only two options. Using two different methods to determine the probability it will snow both the next 2 days. So use two different methods to determine the probability it will snow both the next 2 days. So 0.6 times 0.2 is going to give you it. So compound 0.6 times 0.2 gives it snow on both days. Or you can go through the formula and it's B given A. So just multiplied. Your homework, page 53, 1 to 8 and 11.